Welcome and thanks for joining. What we're talking about today is the difference quotient. So just 3 slides, pretty short. So difference quotient, we're not going to talk too heavily about it right now. What I want you to get down now is just the how-to of performing it. And then way later on in the year, we're going to sort of revisit this and introduce it when we're talking about a different topic. But what is the difference quotient? The difference quotient formula is f of x plus c minus f of x all over c, given that c cannot be 0, because then you would have 0 in the denominator. So what is this really saying? F of x plus c just means that you're going to substitute x plus c into the variable, which, x in this case, of the function. So essentially, I'm going to replace x with x plus c. Then I'm going to subtract the original function and then divide by c. So if we sort of do this in practice, to do the f of x plus c, which I'm going to switch color real quick. So if I'm going to do this f of x plus c, I'm going to write the f of x function, 3, except instead of x, I now have to replace that with the entire quantity, x plus c. And then we have our minus. And next, what we need to subtract is the original function, f of x. Well, f of x is just 3x. And this is all over c. So what I want to do is simplify this to a point where the c in the denominator is gone. So if I simplify this, I'm going to distribute this 3, and I get 3x plus 3c minus 3x all over c. So my 3x minus 3x cancels, and I get 3c over c. The c over c cancels, so I'm left with just 3. Now in this case, we get a numeric answer, but that is not always going to be the case. A lot of times, you're going to get some equation as the answer, some expression, sorry. But here we find that the difference quotient is just equal to 3. All right, I'm doing another example. Sorry, I skipped a little bit too far. Same thing, f of x plus h. So we're just switching the variables so that you get comfortable. You can see either. So in here, I'm going to replace x with x plus h. Now again, I have to replace both of these x's with x plus h. So this will become x plus h squared plus 3x plus h. Now all that I have done is written the f of x plus h. I've only substituted x plus h in for x. Now I still need to subtract, and what I need to subtract is the original function. So I'm going to subtract x squared plus 3x. And this is again all over h in this case. Now remember, my goal here is to get rid of the h in the denominator. So I'm going to have to simplify this as far as I can to eliminate this h in the denominator. What that also sort of tells me is I am going to have to get rid of everything that's in the f of x. All of that is going to somehow have to go away so that eventually I can cancel some h's. And that should help guide you if you're ever doing something wrong, because if your original f of x does not cancel here, then you're sort of probably making a mistake. So if I FOIL this out, x plus h squared, I get x squared plus 2xh plus h squared. Pretty bad too. And then if I distribute this 3, I get 3x plus 3h. Then I need to distribute this negative. So negative x squared minus 3x, also bad too, all over h. Now notice things are going to cancel. X squared minus x squared, 3x minus 3x. So that original function canceled off. And looking at what I have left over, in the top, you will realize that each of the terms has an h. So I can take h out, and I'll be left with 2x. If I take h out of h squared, I'm left with just h. And if I take h out of 3h, I'm left with 3 all over h. So my h over h cancels. And my final answer then is 2x plus h plus 3. So again, in this case now, I got an expression. In the first problem that we did, I just got a numeric value. Now I'm getting sort of a whole expression. All right, and then the last problem, number 3, f of x plus h. I'm going to color code this again. So f of x plus h. I'm going to replace x with x plus h. So -2, replace x with x plus h plus 5. And then it's not the color. I'm going to subtract, also not the color, the original function. I'm going to put that in parentheses, and that is just so that we remember that this negative is getting distributed to both of these. And this is all over h. So simplifying this, I'm going to distribute this -2 to get -2x minus 2h. The plus 5 is not getting multiplied by that -2, so just plus 5. Then distribute this negative, so I get plus 2x and minus 5 all over h. Notice again here, -2x, positive 2x, 5 minus 5. So what we see is that original function canceled off. I'm left with then -2h over h, and my h over h cancels. So my difference quotient gives me -2. Later on again in the year, we're going to talk about what that difference quotient is actually doing for us. And some of you maybe will be able to come up with that. But that's going to be like a huge pivotal topic when we talk about limits all the way at the end of the year, and just, as like an introduction to calculus. So just right now, get down that algebraic way of substituting in x plus h or x plus c and canceling some of that off. Really getting down just how do you do that setup. That's what you're really going to struggle with right now. And hopefully you won't. If you could just substitute in correctly and get that setup down, you're probably going to simplify correct, hopefully. So get started. You should have a worksheet that goes with this, so get to work on that.